Hello everyone. So today we are going to present the bookstore project that we created under the guidance of Professor Daniel Peter in the course CSY 7374. So we are a team of three. That is myself, Divyesh Shah, and my other two mates are Ganeshekar and Ajay. So in this project, we tried to implement all the 11 design patterns that were covered during the lectures, that the following 11 design patterns. Now, talking about the personal contribution, Gunashekar tried to implement the following design patterns, that is facade, adapter, prototype, and builder. Whereas Ajay has given his contribution by implementing the design patterns such as observer strategy and factory singleton design pattern. Whereas myself, I have tried to implement state decorator and command design pattern and have contributed to this project. So basically, in bookstore API is all about the bookstore class in which we are able to add books to the order and then to the order object, and this order now goes to the various different strategies and different state transition. So we'll try to go through all the design patterns one by one. So now I'll hand over to my other teammate, that is Ajay, to explain his contribution, and we'll move forward.
So I've contributed with three design patterns. So starting with singleton, which is used to create a single instance of a class. And we have used two ways using lazy singleton and eager singleton. Then we have got the factory, which is used to create objects of a specific class by making its constructor private. And observer pattern, as we know, it's whenever the state of a certain class change, then all its observers will get notified. Now, just coming to the structure of this entire project. So we have segregated all our individual design patterns into different packages, and then we are having one common package where all the interfaces and all are structured. Now coming to the first part, which is with respect to the strategy. So in my strategy pattern, I'm having two different strategies to provide two different discounts. So we have like employee discount. We have the main interface API discount strategy, and then we have two discounts, employee discount and faculty discount, which has got its own specific calculation. And then like in employee discount at 0.15 and in student discount at 0.20, and it provides a discount according to its calculation. So with this strategy, you get different prices for the same original price. Then coming to the observer pattern. So observer pattern, we have basically in observer pattern, we are having one order observer, which is having updated method. And whenever in a price observer, whenever our total price exceeds a certain limit, in this case 500, then we are setting a discount of 20. And we are passing order, we are taking order as a variable in this one. And also same applies for quantity observer. Whenever our quantity exceeds a certain limit, we are providing a discount. So this was about observer pattern. And now moving on to the factory pattern. So yeah, like basically also in my observer pattern, I'm also having this thing called add book. So this is the way where I'm adding the books, and my observers will be getting updated using this o dot updated this according to the price observer and quantity observer. Now moving on to the factory pattern. So like I've said, in factory pattern we have used two different factories. One is singleton and one is lazy singleton. So basically in abstract factory, what we are doing is that in book factory, we have got this get in book factory, what we are doing is that we are creating a eager singleton by initializing the book factory object right during the start. And then we are just calling get instance, which returns as the object of book builder, which is creating the object for book. Similar thing applies for employee factory, where we have done using lazy singleton, and it does the same thing. So that's it. Yeah, I'm passing on to Gunashikar.
Yes, hi, Gunashekar here. So to create an object of a book, rather than using the constructor, we are using builders, different builders. For example, book builder. This, first of all, builder design pattern is used to create, is used to split the object creation by of a complex object creation. There are two aspects of this builder design pattern. One is a director class, another one is a builder class. Director class holds the structure of the object, and builder class holds the representation of the object. So this book builder class, book builder holds all the representation of an object that is required to create a book class, a book instance. And then when the build method of this builder class is used, using book factory, this particular book object is returned using the representation of the of this builder. and then so this builder class we have used for in two cases. One is for book builder and the other one is for employee builder. So going on to the next design pattern, which is adaptive design pattern. So let me open up the design pattern. So the adaptive design pattern is used to adapt a legacy code with the client code. So in our case, book is a client, is our client code. When the book author name, when the book author is requested from directly in the book object, the name of the book is returned actually. But when we adapt author class with the book class using adapter, you see here author adapter has, again through the author adapter we can dynamically supply book object as well as author object. So when the get book author method is called, rather than returning the author name after adapter, we are returning the whole author object, which you can see here. Rather than returning just the book object, we are returning whole author and as well as the book that he has written. So therefore we have adapted the author object with the book object. Author is a legacy, book is a client. And going on to the next design pattern, which is a facade design pattern. And by the way, let's go to prototype first. We have used prototype design pattern in the author class. Author implements clonable. This clonable implements clonable. Clonable implements object. So when the clone method of this author is called, it returns the clone of an author object, which is so using this prototype design pattern, we are calling off the necessity to create a new object using class constructor, but rather this we will clone the existing object and return the new object. This way we will save the heap memory. So, and now going on to the next design pattern, which is a facade design pattern. Facade design pattern is used to convert a complex interface to a simpler interface. For example, in our instance, in order to order a book, rather than creating a book object and then adding it to and creating an order object and adding a book to this order and decorator to this order, we are doing all these steps in a single order method of this order facade class. When the order method of this order facade class is called, this method creates an order, and when this book, which is dynamically through object composition supplied to this order facade, this book is decorated and added to this order, and the decorated book is also printed out. This way we have implemented order facade, which takes care of converting a number of different steps using different interfaces to a very simple interface. Next, I'm handing over to the Divyesh. Thank you.
Hello everyone. So I have implemented the three design patterns, such as state, decorator, and command design pattern. So first of all, I'll start with the state design pattern. State is a behavioral design pattern, and the main purpose of this design pattern is that objects can change their behavior at runtime without changing its class. Also, by using the state design pattern, we can make the code clean and by minimizing the use of if-else cases. So now I'll first of all show you the state design pattern. Over here, we have used state design pattern for the two things, that is for bookstore state API, for bookstore state, and for order state. So first of all, I'll walk you through the bookstore state API. So I have created the bookstore state API, which has the following three methods, that is state open, state close, and state stock. So the three classes have been derived from this bookstore state API, that is close state, open state, and stock state. I'll show you the implementation of one of the state, that is as you can see, the state open state class implements the bookstore state API, and it even has a object of bookstore. So if the store is already in an open state, then it will give an error, that is it is already in an open state. From open state, it can either go to state close or it can go to stock state, either of this. So the following will set a state for the particular state and will display this message. Now I'll show you the order state API. So order state API is the following four method, that is awaiting order confirmation, order confirmed, order dispatch, and order delivered. So the following four classes have been derived from which implements the order state API, and it implements the following four methods. I'll show you the code for one of the derived class. So as you can see, like we are here, we have an implementation of awaiting confirmation state class, which implements the order state API. It has an object of an order, and the following four methods have been implemented. So if the order is already in awaiting confirmation state, then it will give an error that is already in awaiting state. In this particular order thing, it can go only from confirmation can only go to order confirm. Order confirm can only go to order dispatch, and order dispatch can only go to order deliver. After once the order has been delivered, it cannot transit to any other state. So this was the implementation of the state API, and even all this state has been implemented in the demonstration has been done in the bookstore demo method. As you can see over here, these are the following five where we tried to implement the state API. Now I'll go on the observer design pattern, which is now I'll go on to the command design pattern, which is a behavioral pattern. So what the command design pattern has four components, that is client, invoker, command, and receiver. So what happens in a command design pattern is client uses invoker to map a command to its receiver and performs the necessary operation. And receiver performs the operation but cannot initiate the operation on its own. So command is used to initiate that operation. All this is done using the invoker class. Now I'll quickly show you the command. That is, we have over here made two classes, that is buy book command and rent book command. These both classes have been implemented from command API, which has the execute method. Over here, now I'll show you one of the implementation quickly. So this is a rent book command, which implements the command API. We have tried to implement this rent book command instance with lazy singleton, whereas the buy book with the eager singleton class. And the execute method will call a respective method for that. Over here now we have an invoker object which on the basis of the command passed from the client, it will call the execute method based on that. So this is our command design pattern. Now decorator pattern. Decorator is a structural design pattern, and this in decorator design pattern is used to add for decorators to the existing classes. So it act as a wrapper for the existing classes. Now I'll show you quickly the demonstration of a decorator class. Since we have decorator, we have abstract class book decorator, which implements the book API, and this has a object of book API, which is decorated book. So it has the following methods. It will show. And now the gift decorator, we have created this decorator which actually as a wrapper for the books which are bought. So it wraps up the book along with the pen. So you can see that it extends the book decorator, and as book description shows that it is wrapped for a gift along with the pen. So this is all the design patterns that we have implemented. So this is all from our 3 side, and thank you so much for hearing us, and thank you so much.